So we're going to take our way through this question about finding the zeros and the vertex of the function. The first thing we want to do is, if you want to find the zeros, you can factor. But instead of that, we're going to try doing it by completing the square. So the first thing we're going to do is set it equal to 0 and bring the constant term to the other side. This is the way we set it up to be able to complete the square. Divide the 3 out of the two terms, and then you're going to be a third term that you're going to have to fill in. On the right hand side, you'll balance it out with the other term that's going to go there. What's the term that's going to go in that blank? Well, you're going to be dividing the -6 by 2 and then squaring it to get that third value. So half of 6 squared is 9. So we'll be adding 9 to that side. But on the other side, to compensate for that adding of 9, which is multiplied by the 3, you're going to have to add 27 on the other side. We now have a perfect square trinomial in the bracket, so we can rewrite that as a binomial squared. On the right hand side, simplifies to 12. Now the goal at this point, yes, we could change it into standard form, but because we're looking for the zeros, we want to be able to isolate the squared bracket and then square root both sides. So get rid of the 3 by dividing it on both sides. Then, simplifying, we now have the squared bracket isolated. We're going to square root both sides, but remember, when you square root both sides, there are two square roots. There's the positive square root and the negative square root, so we put the plus minus in front. The square root of x minus 3 squared is simply going to be x minus 3. And then square rooting the 4 with the plus or minus is going to be plus or minus 2. Works out evenly. That's not going to happen every time, but the thing is, it'll always work. You'll be able to get an answer. It won't always be a nice square root. There are two solutions we're looking for. So I want to isolate the x, so I'll bring the -3 to the other side, plus or minus 2. My two solutions, 3 plus 2 or 3 minus 2. The x-intercept, that's where the two zeros are, can be written as ordered pairs, 5, 0, 1, 0. Now we still have to find the vertex for the function. Rather than restart completely, we're very close in that middle step to getting this into standard form. Take this equation, put everything on the same side, so it'll be equal to 0, and that is your function. And so the final step is to get the vertex out of the brackets. The vertex is going to be positive 3 for the x, which comes from that bracket, and the -4 is the piece sitting on the end. Hopefully that all makes sense to you, and you'll be able to do it on your own.